So next question. 4 coins are tossed 5 times. What is the probability of equal number of heads and tails at least 3 times? And what is the expected number of times heads and tails occur in equal number? So this is the question. 4 coins are tossed 5 times. So let the random variable x denotes the number of heads. And what is the probability of getting a head? P is 1 by 2. Q is also 1 by 2. So 4 coins are tossed. So n is 4. So this x follows binomial with the parameter n as 4 and p as 1 by 2. So what is p of x? P of x is ncx p raised to x q raised to n minus x, where x is 0, 1 up to 4. So this is 4cx 1 by 2 raised to x. Again q is also 1 minus 1 by 2, it is 1 by 2. 4 minus x, it is 4cx 1 by 2 raised to x into 1 by 2 raised to 4 minus x is 1 by 2 raised to 4. So this is the probability of x, that is probability of getting head. Then what question is, what is the probability of equal number of heads and tails at least 3 times? So let it be there at least 3 times. So what is the probability of equal number of heads and tails? Heads and tails are equal means 4 coins are there. So the possibility is 2 heads and 2 tails. So x denotes the number of heads. So let x is equal to 2. So we have to find p of x is equal to 2. It is 4c2 1 by 2 raised to 4. And it is 4c2 is 4 into 3 by 1 into 2. 1 by 2 raised to 4. It is 2 here, again 2, 2q. So 3 by 8. Okay. So the probability of getting equal number of heads and tails is equal number of head and tail. It is 3 by 8. Again, the question is equal number of heads and tails at least 3 times. So we have to define that a new variable, a random variable. So let y be the random variable denoting number of times equal number of heads and tails is heads and tails occur. Okay, so how many times equal number of heads and tail occur? Let it be the new random variable y. So what will be p of y? P of y will be ncy p raised to y q raised to n minus y. And what is p here? P is the probability of getting equal number of heads and tails, and it is already, we have defined the corresponding random variable as x, and p of x is equal to 2 is 3 by 8. So here the probability of equal number of heads and tails is that 3 by 8. And what is n here? N is again 4 coins are tossed 5 times. So y is the random variable denoting how many times out of this 5 times. So n is 5. Okay. So p of y is 5cy 3 by 8 raised to y. Then q is 1 minus 3 by 8. It is 5 by 8. So 5 by 8 raised to 5 minus y. Okay, so this is the probability distribution of p of probability distribution of the random variable y. Then what is the question? What is the probability of equal number of heads and tails at least 3 times? So here we have to find this y. At least 3 means minimum 3 times. So greater than or equal to 3. Okay. So it is greater than or equal to 3 is 3, 4, 5. P of y is equal to 3, 4, 5. Or we can write it as 1 minus p of y is equal to 0, 1, 2 also. So here it is 5C3, 3 by 8 raised to 3, 5 by 8 raised to 5 minus 3, 2, plus 5C4, 3 by 8 raised to 4, 5 by 8 raised to 1, plus 5C5, 3 by 8 raised to 5, 5 by 8 raised to 0. And if you find the sum, you will be getting using calculator, it is 0.0692. Okay. Then there is one more question. What is the expected number of times heads and tails occur in equal number? So we have to find the expectation of this y also. And by definition it is sigma or it is the mean of the random variable y. It is np. Mean is expectation of x is np. So here what is the value of n? It is 5. Then what is the probability? It is 0.0692. So if you multiply this, we get 1.875. Okay. Next, a problem is there. A coin is biased so that head is thrice as likely to appear as tail. So a coin is not unbiased. Unbiased means probability of getting head and tail both are 1 by 2 each. But here a coin is biased. So we can't write P is equal to 1 by 2 or Q is equal to 1 by 2. But the condition is that head is thrice as likely to appear as tail. So probability of getting a head is 3 times probability of getting a tail. So let P be the probability of getting a head. So what will be the probability of getting a tail? It is 1 minus P, or it is Q. Q is equal to 1 minus P. And it is given that P is equal to 3 into 1 minus P. That is P is equal to 3 minus 3P, or P plus 3P is 3, or 4P is 3, or P is 3 by 4. Okay. So Q is 1 minus 3 by 4, it is 1 by 4. If the coin is tossed 5 times, so N is 5. Find the probability of getting at least 3 heads. So we have to define x. X is the random variable denoting number of heads. So P of x is NCX P raised to x Q raised to n minus x. X varies from 0 to n. So it is 5CX 3 by 4 raised to x 1 by 4 raised to 5 minus x. Okay, x is equal to 0, 1 to 5. So this is the probability distribution function. So first question is find the probability of getting at least 3 heads. So x is greater than or equal to 3. So it is P of x is equal to 3, 4 and 5. So what is it? P of 3 plus P of 4 plus P of 5. And it is P of 3 is 5C3, 3 by 4 raised to x, 1 by 4 raised to 2. Plus P of 4 is 5C4, 3 by 4 raised to 4, 1 by 4 raised to 1. Plus 5C5, 3 by 4 raised to 5, 1 by 4 raised to 0. And if you add these probabilities, you will get the probability that at least 3 heads. Second one is at most 3 heads. So x is less than or equal to 3. So it is P of x is equal to 0, 1, 2, 3. Okay. So it is P of 0 plus P of 1 plus P of 2 plus P of 3. So it is 5C0, 3 by 4 raised to 0, 1 by 4 raised to 5. 5C1, 3 by 4 raised to 1, 1 by 4 raised to 4. 5C2, 3 by 4 raised to 2, 1 by 4 raised to 3. Plus 5C3, 3 by 4 raised to 3, 1 by 4 raised to 2. Okay. Then third one, exactly 3 heads. So x is equal to 3. So it is 5c3, 3 by 4 raised to 3, 1 by 4 raised to 5 minus 3, 2. Okay.